This video is made by Knowledge Link Information. It will gives idea about solar electric generation system and components explanation. Sunlight. Sunlight, also known as sunshine or solar radiation, that visible on Earth's surface. The amount of sunlight depends on cloud covered during the time. Sunlight have three major components. Number 1, visible light with wavelength between 0.4 and 0.8 micrometers. The visible light constitutes a half total radiation on Earth's surface. Number 2, ultraviolet light have wavelength shorter than 0.4 micrometers. This ultraviolet light have only a very small proportion of a total radiation. The ultraviolet light radiation has both positive and negative health effects, as it is both requisite for vitamin D3 synthesis and mutagen. Number 3, infrared radiation that have a wavelength longer than 0.8 micrometers. This infrared radiation is heat producing quality and give half of total solar radiation on the Earth's surface. Sunlight is a key factor in photosynthesis, in which the plant and other autotrophic organisms use light energy to convert chemical energy to fuel themselves. They absorb sunlight and convert into nutrients through a process of photosynthesis. This photosynthesis is also responsible for all fossil fuels on Earth. The producers or autotrophs are plant, algae, bacteria, and fungi is the foundation of food web. Scientists estimate the first autotrophs evolved on aquatic setting about 3 million years ago. Solar energy. Solar energy is created by nuclear fusion in the sun, which is necessary for life on Earth and can be harvested by human like electricity. The fusion occurs when protons of hydrogen atoms are violently collide in the sun's core and fuse to create helium atoms. This process, known as PP, proton-proton chain reaction, which emits enormous amount of energy. About 620 million metric tons of hydrogen every second in the sun's core. The PP chain reaction occurs in other stars also that give them a continuous energy and heat. The Earth receives 174 petawatts of incoming solar radiation of the upper atmosphere, but 30% are reflected back to space, while the rest absorbed by clouds, lands, and oceans. Solar energy is a radiant light and heat from the sun. Solar radiation is the light that also known as electromagnetic radiation, which emitted by the sun. The large magnitude of solar energy available that makes it a highly source of electricity. Nowadays, Human discovered the uses of sunlight energy that converted into electrical energy by means of solar panel absorption. Human discovered that sunlight is a portion of the electromagnetic radiation given by the sun. Solar technologies depends on solar energy for a different uses like generating electricity and heating water. Solar panels. This is a solar panel or photovoltaics. It can directly generate electricity from sunlight. The photovoltaic is a Greek word photos, light of the light, that combined to the name of the Italian physicist Alessandro Volta, known as Volt. A photovoltaic effect means a generation of electrical power of PV cell, semiconductor P-N junction photodiode, when exposed to visible light or other electromagnetic radiation. The generation of the charges are due to the absorption of photons in the PV cell to form a junction and separate the photo-generated charges on the junction terminals. The first silicon photovoltaic cell was developed in year 1954. And the first solar cells that converted a solar radiation to electricity is only 4% efficiency rate. The solar panels are made up of mini solar cells. And the solar cells are also made of silicon like semiconductors that constructed with positive and negative layers. 6 components of a solar panel. Number 1. Solar PV cells is a very thin wafer which is 0.1 mm thick and from either a positive P-type silicon or negative N-type silicon. Number 2. Glass is a high-strength tempered glass that have a 3.0 to 4.0 mm thick to resist mechanical load and high temperature. Number 3. Aluminum frame is designed to be lightweight, stiff, and can withstand extreme stress and loading from external forces. This frame protects the edge of the laminated housing section of the group of PV cells and used for mounting attachment of solar panel. Number 4. EVA, ethylene vinyl acetate film, was designed as polymer highly transparent plastic layer to hold the PV cell in position. This film also helped the solar panel lifespan and performance because it prevents the PV cell from moisture and dirt ingress. Number 5. Back sheet is a back layer that acts as moisture barrier and provide electrical insulation and mechanical protection. Some solar panels do not use a back sheet, but they use a back glass to make bifacial, which term as dual glass panel. Number 6. Johnson box and connectors is a weatherproof enclosure securely attached at the back side of the solar panel for central point connection of PV cell sheets, bypass diodes, and positive or negative external cables. A solar panel generates direct current electricity in which electrons flow in one direction when electric field created. Our sun is a natural nuclear reactor that releases a tiny packets of energy called photons. These photons can travel 93 million miles from the sun to the earth in about 8.5 minutes only. The photons hit a solar cells and knock electrons from their atoms. Then, conductors are attached to the positive and negative side of cells that forms electrical circuit. At this time, DC electricity is generated when electrons start to flow in the circuit. Multiple cells make up a solar panel, and multiple panels or module can be connected together to form a solar array. Remember that the more panels you can install are the more energy you expect to generate. There are types of solar panels based on their generation. First generation solar panels are traditional types that made of monocrystalline silicon or polycrystalline silicon. Number 1. Monocrystalline solar panel. Mono Si is the purest one because the silicon's high purity have a highest efficiency rates, which reach above 20%. It has a high power output and cannot be affected by high temperature. You can easily recognize a monocrystalline solar panels because it has a uniform dark look and the round edges. Number 2. Polycrystalline solar panel, Poly Si, are made by a melting raw silicon and low efficiency rate, which around 15%. This type of solar panels have shorter lifespan than monocrystalline solar panels since they are affected by hot temperatures to a greater degree. You can distinguish this polycrystalline solar panel by the angle of the squares are not cupped and has a blue speckled look. Second generation solar panels. Number 1. Thin film solar cells, TFSL, are solar panels that manufactured by placing one or more films of photovoltaic material like silicon, cadmium, or copper. These types of solar panels are flexible and less affected by high temperature but shorter lifespan than monocrystalline and polycrystalline solar panels. Number 2. Amorphous silicon solar cell, ESI, are types of solar panels that uses a triple layer technology, which is the best of among thin film design. This type of solar panel is used mainly in pocket calculators that have a thickness of 1 micrometer and only 7% efficiency rate. Third generation solar panels are solar panels included a variety of thin film technology, but most of them are still on research development. Number 1. Biohybrid solar cell are still on research phase that take advantage of the photosystem 1 and emulate the natural process of photosynthesis. The biohybrid solar cell used plenty materials that similar to the traditional methods which combined a multi-layers of photosystem 1. This photosystem 1 is the conversion from chemical to electrical energy that become more effective, which up to 1,000 times more efficient than the first generation solar panels. Number 2. Cadmium telluride solar cell, CDTE, is a solar panels uses cadmium telluride, which enables the production of solar cells and requiring the least amount of water for production. This type of solar panels are relatively cheap and the payback time is less than a year. The only disadvantage of using cadmium telluride are being toxic when ingested or inhaled. Number 3. Concentrated PV cell, CVP, and its CVP are related to what make them so efficient rate up to 41% compared to other type of solar panels. These type of solar panels are the highest efficiency because of curved mirror surface, lenses, and cooling system, which used to bundle the sun rays to increase the efficiency. It is a type of solar panels that can only be efficient if they face a sun on perfect angle, in which solar trackers inside was following the sun. Effect of clouds in solar panels absorption. Solar panels will not operate at maximum production or absorption when clouds are blocking the sun. The amount of power in your solar panels can produce depends on the level of light they receive. The solar panels produce the maximum power capacity in full bright sunlight. Solar panels will produce only a little useful power when clouds or thicker clouds covered the sunlight. But there are some surprising good benefits of clouds that your solar panels produce an ultimate peak power. Your solar panels can produce peaks or above 50% more than its direct sunlight when sun moves into a hole of clouds. The sunlight reflected from the clouds around the hole and maximum sunlight reflection goes directly in solar panels. Solar charge controller. Solar charge controller or solar charge regulator manage and regulate the power charging process from solar panels going to the battery bank. This solar charger protects the battery not to overcharge during daytime and not to run the battery power backwards to solar panel on night time. They are used in off-grid and hybrid off-grid to regulate the power from PV array to battery bank. Some solar charge controller was created with additional protection capabilities like load control, lightning protection, and other features. Solar charge controller have 4 multi-stage battery charging. Number 1. Bulk charging that charges the battery to 80% or 90% SOC, state of charge. Number 2. Absorption charging that charge the battery to approximately 98% is OC, state of charge. Number 3. Float charging is happened after absorption that counteracts the time loads to prevent discharge. Number 4. Periodic equalization charging for flooded open vent batteries to maintain specific gravity consistency of all cells. We have 3 steps of connecting solar charge controller. Number 1. First is to connect the battery to solar charge controller. Number 2. Then, connect solar panel PV array to solar charge controller. Number 3. The last connection are electrical load to solar charge controller. You must only reverse the 3 steps when you disconnect solar charge controller to avoid damage of the charge controller. To reverse the step during disconnection of solar charge controller are the following. Number 1. First thing to do is to disconnect electrical load from the solar charge controller. Number 2. Then, disconnect the solar panel PV array from the solar charge controller. Number 3. The last disconnection is battery from solar charge controller. There are 2 main types of solar charge controller based on their performance technology. Number 1. PWM, pulse width modulation. Solar charge controller have a direct connection from solar panel array to battery bank. This type of solar charge controller uses a transistor rapid switch to modulate the current and maintain a constant voltage to control battery charging. The PWM solar charge controller works good, but the only problem is the solar panel voltage is pulled down to match the battery voltage. Number 2. MPPT, maximum power point tracking. Solar charge controller are more precise that operate only maximum power point to 30% more efficient depending on the battery voltage and solar panel voltage. The first MPPT solar charge controller was invented in 1985 at small Australian company named AERL. Some MPPT solar charge controller can detect partial shading and able to track multiple power points to increase the amount of energy up to 30% than PWM solar charge controller. Make sure that your solar charge controller has extra rated amperes than your solar panel amperes, so that it can absorb the surge when sun reflects in the cloud and give maximum sunlight. Solar battery storage. You can have a backup power supply when the sun is not shining or during nighttime if you have a battery power storage that connected in the solar panels. The battery will discharge to support the load consumption when the solar panel electric generation is weak during day and nighttime. We have two types of connection in solar electrical system. Number 1. Off-grid solar connection that still have a power source during nighttime without depending on the local electricity due to a battery storage connected to the solar panel. Number 2. On-grid solar connection that do not need any battery storage because it is parallel connected and dependent to local power grid system. This type of connection can save money if have a lot of sunny days in which the surplus of electrical energy feed back to grid and paid by power company. On-grid connection are still dependent to local power grid because it is affected with power outage during nighttime and no power at all. You need battery as energy storage if you choose the off-grid solar connection. To have energy storage battery of your solar system can provide a number of benefits like emergency backup power to even financial saving. You should know the battery power rating in kilowatt to sustain and provide enough power to run your appliances. You should also aware that two different power ratings of the battery so that you can run a correct type of appliances in long hours. Number 1. Continuous power rating, in which the battery provide normal power to a normal operation of appliances. Number 2. Instantaneous power rating, that a battery can provide more power in high starting current and run normally in low power. You must know also the capacity of battery in kilowatt hour on how much the amount of electricity can store and supply to your appliances on a specific number of hours. Generally, most solar batteries are deep cycle battery, which allow to discharge up to 80% on the stored energy before recharging. The three different chemical composition of solar batteries. Number 1. Lead acid batteries was used in off-grid energy system for long time ago until now. This type of battery have shorter lifespan and lower depth of discharge (DOD) compared to lithium-ion battery. Number 2. Lithium-ion batteries have longer lifespan, lighter, more compact, and higher DOD than lead-acid battery. This lithium-ion battery also used for solar power backup storage to be more attainable. Number 3. Salt water batteries do not have heavy metals and only rely on salt electrolysis. This type of battery is more environmental friendly and can be recycled easily, but technology are still on research to this battery. Solar inverter. Solar inverters converts the direct current output of solar panels into 110 volts AC or 240 volts AC, which supplied into your home appliances. The first inverter that has only spinning motors used to a continuous change of DC source in forward or backward rotation was created in 19th century. But inverter nowadays was improved to electrical switches out of transistor, which is a solid state devices that no moving parts. Transistor is a semiconductor materials like silicon or gallium arsenide that control a flow of electricity in response to outside electrical signals. Types of solar inverter. Number 1. String solar inverter are connected in series to a string of solar panels that link together. These string solar inverters are most popular type and common type of inverter. Number 2. Hybrid inverter are battery-ready inverters that combine a solar inverter and battery inverter together in one unit. This type of inverter can provide a basic level of backup power during blackout and become more competitive from other inverters. Number 3. Off-grid inverters or stand-alone inverters are used in isolated system in which these inverters draw its DC energy from battery that charged by solar panels. Some stand-alone inverter have integrated battery charger to recharge the battery from AC source on utility power grid and not required anti-island protection. Number 4. Battery backup inverters required to have anti-island protection and do not have built-in battery charger. This type of inverter is dependent to the external battery charger and from battery storage for supplying AC power to a selected loads during blackouts. Number 5. Micro-inverters are very small solar inverters that connected directly to individual solar panels. This type of inverter do not need any battery storage because it converts the DC energy to AC energy and directly feed to the loads. Today, inverter have already single-phase inverter design, three-phase inverter design, and energy storage inverter. Inverter have different types of classification based on their output characteristics, source, type of load, connection, and PWM, pulse width modulation technique. We have three output characteristics of inverter for powering AC loads. Number 1. Square wave inverter used for some resistive loads. Number 2. Pure sine wave inverter used for general application. Number 3. Modified square wave inverter. Used for resistive, capacitive, and inductive loads. 2 source type of inverter. Number 1. VSI, voltage source inverter. This inverter input keeping a constant voltage, and the load current waveform and magnitude depends on the load impedance. Number 2. CSI, current source inverter. This inverter input keeping a constant current, and the output voltage waveform and magnitude depends on the load impedance. 2 types of load supply inverter. Number 1. Single phase inverter that convert DC input to single phase AC voltage output and 50 or 60 Hz frequency, which used for residential load supply. This inverter can be manufactured with full bridge or half bridge. Number 2. 3-phase inverter that convert DC voltage into 3-phase AC supply, which have a high power and variable frequency application for high voltage power transmission of industries. The conduction mode of 3-phase inverter can be 180 degrees or 120 degrees. Mostly, all inverters possess PWM technique that use MOSFETs in switching the output stage to produce variable AC voltage. This PWM inverter have 4 types. Number 1. SPWM, single pulse with modulation. Number 2. MPWM, multiple pulse with modulation. Number 3. SPWM, sinusoidal pulse with modulation. Number 4. MSPWM, modified sinusoidal pulse with modulation. 2 types of component connection of inverter. Number 1. Series inverter, also called self-commutated inverter or load-commutated inverter, in which thyristor on the circuit are commutated by itself from load. The commutating component of inductor L and capacitor C is series connected with load resistive RL. Number 2. Parallel inverter or center tap inverter have center tap transformer between driving circuit and load to change DC power into AC power voltage. The commutating component is capacitors C are parallel with load through transformer. Transfer switch. Transfer switch is an electrical switch that makes a transfer selection between 2 power sources in one load. We have two designs of transfer switch. Number 1. Manual transfer switch is manually operated by throwing a switch from one source to another source. Number 2. Automatic transfer switch, ATS, are automatic transfer and trigger when it sends from one lost power source or gain power source. 4 types of transfer switch. Number 1. Open transition transfer switch or break before make transfer switch will break the contacts of one power source before it makes another contacts of another power source. This design prevents backfeeding of power from one source to another source. Number 2. Closed transition transfer switch or make before break transfer switch is always used for emergency power system. This CTTS transfer switch inherent a momentary power interruption to the load when transferring from one available source to another power source. Number 3. Soft loading transfer switch, SLTS, is commonly used to operate and synchronize on-site power generation in parallel to utility power. It will also minimize voltage or frequency transient during a transfer of loads between two power sources. Number 4. Static transfer switch, STS, used a silicon-controlled rectifier, ECR, as a power semiconductors to transfer a load between two power sources. This type of transfer switch can transfer the load quickly because no mechanical moving parts. Circuit protection device. Circuit protection device is a voltage and current sensitive devices or weak link component that protect the circuit and prevent damage. These circuit protection devices are very important because it will protect the installation of being safe during high current fault. Different types of protection devices. Number 1. Fuse is an electrical device that consists of metal strip that liquefies when high flow of current on the circuit, and it is one-time used or disposable. The fuse in the market today have different types based on their current ratings, specific voltage, response time, application, and breaking capacity. Number 2. Circuit breaker is an electrical switch that protects circuit against short circuit and can operate automatically or manually restart. This circuit breaker have different size current rating from small devices to large switchgear to protect low current circuit to high voltage circuit. Number 3. Poly switch or reseatable fuse or multi-fuse or polyfuse is a passive electronic component which is similar to PTC thermistor that used to protect electronic circuit from overcurrent. Number 4. RCCB, Residual Current Circuit Breaker, or RCD, Residual Current Device, will turn off only the supply in 10 to 15 milliseconds when somebody get electrical shock. This is a reseatable device that incorporates with some types of MBC, miniature circuit breaker, or a fuse which guards against overload current in the circuit. Number 5. Inrush current limiter are like a fixed resistor or NTC thermistor used to stop inrush current to avoid damage of equipment and blowing of fuse or tripping circuit breakers. It is a type of electrical component which make a high resistance to stop a huge current from flowing throughout in normal operation. Number 6. Lightning protection. Have MDR, metal oxide varistor, and has gas discharge tube. The VDR of lightning protection will change resistance which depends on the voltage applied. Meaning that VDR has varistor, variable resistor, which decreases resistance if lightning strikes that increase voltage to protect electrical circuit not to damage from lightning extreme voltage. Number 7. ESD, electrostatic discharge protection, is a device that can be utilized with Zener diodes, varistor, and suppressors which protect electrical or electronics circuits. Number 8. SPD, surge protection device, is connected in parallel of power supply circuit to protect the whole electrical system against from over voltage. Solar cable. Solar cable or PV wire or PV cable are high UV radiation resistant cable that can operate a wide range of ambient temperature from negative 40 degrees Celsius to 100 degrees Celsius. This solar cable is weather resistant and guaranteed for long operation in solar power generation system. The solar cable can be single core and double core, which have positive and negative color code. Solar cable have different manufacturing design that can be used in indoor, outdoor, explosion areas, free hanging, movable, fixed installation, and buried in ground. Calculation of solar cable size must be based on standard EWG, American Wire Gauge chart. Inches is a measurement of wire diameter in American Wire Gauge. Mm squared or millimeter squared is a measurement of cable wire size in Europe standard. Solar connectors. Solar connectors are used to connect solar panels to other panels, batteries, and junction boxes. MC4 connectors are most common type, which is single pole standard that has built-in strain relief and interlocks. There are also branch connector available in the market to assist a parallel or series connection of a multiple solar panels. The other solar connectors that available in the market today are cable couplers, panel receptacle connectors, in-line fuse connectors, and junction box connectors. All 12 volts equipment loads can be connected directly to battery supply or in solar charge controller specified terminals. The AC 220 volts or 110 volts equipment loads are connected on the specified inverter output. This is how sunlight converted to electricity. When sunlight absorbed by solar panels, the solar panels converted the sunlight to DC electricity and controlled by solar charger before it fed to the battery storage. Then, battery storage supply directly to DC equipment loads. The battery storage also can feed DC to AC inverter that supply AC equipment loads. The on-grid solar power system that links to utility watt meter that no need battery storage. This is the off-grid solar power system that uses battery storage. How to design the off-grid solar power system? The off-grid solar power have major components to be designed and calculated, like solar panel, solar charge controller, battery bank, inverter, and loads. This is how to design and calculate off-grid solar power system. Number 1. Determine the power consumption demands. Find the total power and energy consumption by calculating the appliance's total watts-hour per day. Example: a house have 60 watts electric fan used in 3 hours per day and 36 watts fluorescent lamp with electronic ballast that used in 3 hours per day. Total watts of appliance used is 60 watts times 3 hours plus 36 watts times 3 hours is 288 watts-hour per day. And total solar panel energy needed is 288 watts per day times 1.3 energy lost in the system is 374.4 watts-hour per day. Number 2. Size of solar panel. The system will be 12 volt DC, 50 watts solar panel. To find the total peak watt is total solar panel energy divided by 3.4. Total peak watt of solar panel capacity is 374.4 divided 3.4 is 110.12 peak watts. Then, the total number of solar needed, total peak watt divided by expected solar panel watts. 110.12 divided 50 watts solar panel is 2.2 or 2 pieces modules of 50 watts solar panels. Number 3. Solar charge controller sizing. Select solar charge controller to match the voltage of solar panel and battery. Solar charge controller ratings is total short circuit of solar panel that multiplied by 1.3 energy loss in the system. Solar charge controller ratings is 2 PC solar panels times 3.01 amperes times 1.3 system energy loss. 7.83 amperes or greater amperes at 12 volts system. Number 4. Battery sizing. The battery type recommended for solar system is deep cycle battery. Total watts of appliances used is 288 watts-hour per day. Days of autonomy is 3 days no sunshine. Characteristic of deep cycle battery used. Nominal battery voltage is 12 volts. For battery loss is 0.85 or 85%. For battery depth of discharge is 0.6 or 60%. Battery capacity in ampere hour is total watts hour per day used by appliances divided by 0.85 times 0.6 times nominal voltage and multiplied by days of autonomy. Battery capacity is 288 watts hour per day divided 0.85 times 0.6 times 12 volts times 3 days is 141.2 total ampere hour required. The battery should be rated 12 volts 150 ampere hour for 3 days autonomy or 3 days no sunshine. Number 5. Inverter sizing. The inverter size should be 25 to 30% bigger than the total watts of appliances to be run. Total watts of appliances is 60 watts plus 36 watts is 96 watts. Inverter size is 96 watts times 30% plus 96 watts is 28.8 plus 96 watts is 124.8 watts or greater wattage of inverter to be used. From all the computation we have done, 30 watts electric fan that used in 3 hours per day and 36 watts fluorescent with electronic ballast that used in 3 hours per day needs 2.2 or 2 pieces 12 volts DC 50 watts solar panels. 10.83 amperes or 10 amperes solar charge controller. 141.2 ampere hour or 12 volts 150 ampere hour battery bank. And 124.8 watts or 150 watts solar inverter. I hope that this video content can give you a small ideas. Thank you for watching. Please subscribe, like, share, follow, and good comments to all the videos of knowledge link information.